process, you can say that is a physical process or a chemical process. What you can say? The process of welding, is that a physical process or a chemical process?
I think both.
Chemical, sir.
Almost you can say that is a chemical process, because in that the metal bonding structure occurs.
Yes, sir.
Isn't it? So metal bonds occurs, metal bonding structure occurs, and if you are saying it is a chemical reaction, definitely other than the bonding structure, the other chemical reactions might be happening, just like oxidation or inclusion, heat production, light production. So other form of energy release is also being involved in the welding process, isn't it?
Yes.
So major side reaction to this melting type welding process is your oxidation, isn't it?
Yes, sir.
So during welding process, if oxidation occurs prominently, then definitely the welding process will be a failure because of poor bonding structure. And poor bonding structure, how it will happen? Because of the oxidation, isn't it?
Yes, sir.
So do we take any precaution or care to avoid oxidation during welding process? Do you know any procedure, any process by which we take care of this oxidation not to happen?
So we can use shield glasses.
You can use
Shield glasses to cover face.
फेस को कवर करने से क्या होगा? मेटल में तो ऑक्सीडेशन होगा ना, फेस में थोड़ी ऑक्सीडेशन होगा.
सर वो गैस यूज करते हैं सर,
गैस,
पंजिंग गैस यूज करते हैं.
कौन सा गैस?
प्रोपेन गैस यूज होता है शायद.
ओपन गैस,
प्रोपेन सर.
प्रोपेन.
यस सर.
प्रोपेन गैस यूज करके वेल्डिंग करते हुए कभी सुना है, देखा है? आई डो नॉट नो. There are some easily available inert gases are there, and most common inert gas available is your argon gas. Okay, so most gas using welding processes uses argon as inert gas. Okay, so just to seal the welding area. Okay, and use of propane gas, I do not know. As you are saying, somebody is saying about propane gas, that I do not know, that I have never heard of. Okay, and using inert gas will make the welding process very costly, isn't it? Yes or no? If you are using inert gas to avoid oxidation and cover up the welding zone, then definitely that will be very costly process. Along with the welding, you have to again put the inert gases to the welding zone to cover it, isn't it? So is there any other simple, cheaper process in which we can avoid oxidation to the welding zone? Anybody knows it? So basically we use flux. About flux, students, do you know? Flux, F-L-U-X, flux.
Yes, sir.
So flux is a material which is used as a covering material to cover up the welding zone. Okay, and this flux material basically coated around the electrode in general. Okay, But there are some industry-oriented welding procedures in which the flux material is being supplied externally, some other source. But in general welding procedure, the general welding procedure which you might have seen in the welding shops or garages, so there the flux they are using, that is basically coated around the electrode. So do you know, students, the electrode? What is an electrode? What is an electrode? Students, what is an electrode?
Sir, conductor, sir.
For welding, we need the positive current and the negative current to be close enough so that the spark will produce, isn't it? And when spark will produce, the spark zone, the temperature will be very high, and that will melt the material. That will melt the metal, isn't it? So basically, in the electric welding process, we put the positive or anode to the workpiece, and the cathode or the negative connection we give it to electrode. So electrode is basically a negatively charged metal which also being used as a filler material also. Okay, so basically during welding process, the electrode or the filler material melts, and it compensates the materials required for the bonding or the welding process, and it joins the metals, base metals. Okay, so basic welding procedure you might have seen in your welding garages before this class, isn't it? So I think the welding procedure, electric welding procedure, how it is being taken up, all of you have a little bit of idea. Have you seen electric welding procedure, students, before this? Yes or no?
Yes, sir.
All of you? Anybody who have not seen the electric welding procedure?
So I haven't.
Not seen?
No, sir.
So let me give you a glimpse of electric welding procedure from YouTube video. Basically, we call it electric arc welding. Electric arc welding. Okay. So,
and allows the operator to safely
audio is clear, students?
receiving an electric shock. The rod can be positioned in the holder in a number of
Students,
different
audio is
ways,
clear?
depending on operator preference or the position of the work being welded.
Yes, sir.
When the
So you see
welding
here,
machine is on and the ground clip is connected to,
so you can see here, this is your base metal. All of you can see my arrow, isn't it?
Yes. Yes, sir.
My cursor arrow, all of you can visualize, isn't it? Which I am rolling it on the video screen. Okay. So this is your base metal in which one connection is given. This is your positive connection or the cathode anode connection. This is given to the work material. Basically, we call it the base material as work material. Okay. And the part of the connection which this person is holding here over with hand, that is your anode, cathode or negative point. Okay, so to the negative or cathode point, this you can see this rod which is being attached. This is a electrode material. Okay. Now this electrode material he is using for electric arc welding. Okay, so let us play this video and let us see how this welding procedure is being taken out.
The steel table or the work itself, anything metal on this table is now charged.
Still
When the electrode makes contact with the work, it completes a circuit. The electricity flowing
सर
through
आपका माइक म्यूट कर दीजिए
the electric.
Yes.
सर आपका माइक म्यूट कर दीजिए जब ये वाला चल रहा हो सर क्योंकि
Okay.
electrode holder down through the work and back out through the ground clamp back to the welder. When an arc is struck, a common pool of molten metal is created between the two pieces that are being joined. Into this, the melting alloy center of the welding rod is deposited, completing the weld. One thing to be careful of, as you're welding, this rod is being consumed. That is, it's growing shorter. So that the operator has to constantly be aware of both moving the rod laterally, but also pushing the rod into the seam being welded. The first step in learning how to arc weld is learning how to strike the arc. Striking the arc can sometimes be very difficult at first. It's a delicate flicking motion. It's not a stabbing or a quick drag, but as if you're striking a match gently. Once the arc has started, the trick is to maintain a nice smooth molten puddle of metal with a consistent distance between the tip of the welding rod and the surface of the work. All right, let's give it a try. Welding hood's down. Remember, never look at an arc with the naked eye. Now that you've mastered striking the arc, and it may have taken you several tries, don't be discouraged. Let's join some metal together. Okay, hood's down. After striking the arc, I create a nice even pool of molten metal. You'll notice that the tip of the welding rod stays very near to the arc puddle, and that I'm also slightly wavering the tip of the electrode back and forth. The idea is to heat both pieces of metal evenly as the filler rod is being deposited. Once you've completed your arc welded seam, you'll notice that there's a blue-black residue on top of the weld. This residue is a byproduct of the burning flux. It needs to be cleaned away from the weld. You can do this with a chipping hammer, and wire brush.
It's the last ball of the day and he's on 99. What will he do?
Okay, students, have you seen, those who have not seen what is arc welding, to this video, I think you have known what is arc welding. Okay, so such type of arc welding we are going to learn in this EMS lab class. Okay?
Yes, sir.
Yes,
So
sir.
now I am going to play the arc welding experimental video one by one, and we will learn out of it.
This is the welding section. The purpose of welding is joining the metals.
Okay, students, video is clearly visible.
Yes, sir.
So now I am going to start the video.
This is the welding section. The approach of welding is joining the metals. First we start from the definition of welding. Welding is the process by which two similar or dissimilar metals may be joined by heating them to a suitable temperature with or without the application of pressure and with or without the use of filler metal. But always the melting point of the filler metal should be little lower or as same as the base metal. That means in that process we can join both similar metal as well as dissimilar metal. It may be ferrous, it may be non-ferrous. How? By producing heat. When you produce the heat, the temperature depends upon the melting point of the metals, which metal we have taken, and according to that, which filler metal we have taken, according to the diameter of that filler metal, we can adjustment the current. And that formula where we can adjust the diameter of the electrode what we have taken into 40 plus or minus 20 to adjustment the current. And at that time of welding, the current and the filler metal when we have taken and that position also depend upon that there. Then the application of welding. What is the application of welding? Where it's applied? It is mainly applied in the fabrication work. Fabrication matlab decks, bench, chair, table, grill, guardrails, then automobiles, the body of car, bike, ships, vessels, aircrafts, construction. Nowadays welding is very much essential in the different joints when you have required. Then the classification of welding. In a broad category, welding can define classify it having different ways, mainly pressure or not using that pressure welding or non-pressure welding or fusion welding process. Where we can apply some pressure, that is pressure welding. Where we have not required that pressure, that non-pressure welding. Then according to the source of the electric current and the mixture of gases, that is the process is arc welding and the gas welding. Then we have elaborated different, more than 30 process weldings are there. But you have that in the first semester, you have that process which is the shielded metal arc welding process, which is performed in your own hand, manual welding process. Then what is arc welding? In the arc welding, the source is the electric current. The main source is the electric current. The arc is stable between a consumer electrode and the workpiece. And then the gas welding, where the source is a mixture of two gases to produce a flame. In the case of a gas welding, we have used different types of gases, which is combustible gas, another is support to combustible. Different types of combustible gas such as acetylene, hydrogen, propane, methane, coal, support to burn oxygen and air. By mixture of two gases, then suppose oxygen mixed with acetylene, oxyacetylene, oxygen hydrogen, oxyhydrogen, oxygen propane, oxypropane, oxygen methane, oxymethane, etc. And generally we are using here oxygen and acetylene gas, so that it produces oxyacetylene flame. What is the oxyacetylene flame? The flame is nothing, that is only the chemical reaction of the both gases, oxygen and acetylene. In front of the blowpipe nozzle, we can sparking or firing the flame produced, that is the oxyacetylene flame. I'll show you when you start the process of gas welding if you have time to complete the arc welding process. Then they are divided of oxyacetylene flame, neutral flame, carburizing flame, oxidizing flame. How to produce the neutral flame? What is the flow of the gas? What is the flow of the gas for the purpose of carburizing flame? What is the gas flow for that oxidizing flame? In neutral flame, both gases flow equal percentage. Ratio is 1:1, both oxygen and acetylene. How we can know the flow of the gas is equal? There is no measurements. By the inner cone. The inner cone looks like rice. In the carburizing flame, the inner cone looks like a white envelope surrounding the inner cone. And in the oxidizing, that is pointed. In carburizing, more percent acetylene, less percent oxygen is required to make this flame. In oxidizing, more oxygen and less percent of acetylene is required to make this flame. Then the temperature, how much it is produced, approximately temperature we have taken for that neutral, that is 3200, for the carburizing flame 3100, and oxidizing 330 degree 3300, 100 degrees centigrade. Okay. Then when we go for the purpose of arc welding, before that we know about that arc length. What is the arc length? Straight distance between the tip of the electrode and job surface when arc is formed. It is the straight distance between the tip of the electrode and job surface when arc is formed. This is the electrode. These are the two workpieces. We are going to start welding. Where the tip of the electrode and the workpiece, when we contact, then we can find the spark. After sparking, when it's ionized, we can maintain the distance between the tip then the workpiece. The distance after formation is known as arc length. Three types of arc length: medium arc length, short arc length, long arc length. What is medium arc length? If the distance between the tip of the electrode and job surface is equal the diameter of the core wire, it is known as medium arc length or normal arc length, which it is suitable to better weld, good penetration, and the welding is better stronger than the better after weld. Short arc length, if the distance between the tip of the electrode and the job surface is less than the diameter, then that is short arc length. If we can perform by the short arc length, due to imbalance of the hand, when we can perform the manual weldings, the bead which perform, that is less amount of deposition, so that welding is not better stronger. Some welding defects occurs during that time due to that. Long arc length, if the distance between the tip of the electrode and the job surface is more than the diameter of the electrode, then it is length. If we can perform at the long arc length, then more sputter occurs. Then some welding defects occurs when you study about that welding defects. Then we study about the different types of joints. Mainly in welding there are two types of joints. One is the butt joint, another is the fillet joint. Butt joint side by side, angle should be 180 degree. This is the one example of a butt joint, which diagram already performed. When we have taken more than thickness millimeter 6, we have required between two workpieces maintain the root face and the root gap where we can pour that material. For that, there we have necessary to prepare the edge preparations. According to the edge preparations, the butt joints are classified single B, double B, single U, double U, single bevel, double bevel, single J, double J, etc. In case of butt joints, then fillet joints, one is overlap each other. Lap joint, corner joint, E joint, and another one is the edge joint, which diagram is not here. If we can perform somewhere single side lap joint, another both side for the lap joint, both side welded. Here it is the single side, it is the both side, T joints, single side, T joint, double side, lap joint one side, lap joint both side. These are the diagram which show to you. According to the joint designs, when you go for the welding, the welder must have to know about the position of the welds according to that structure. According to the structures, when we can go for the different joint design, 4 positions come out: flat, vertical, horizontal, overhead. Flat means in the downward direction. Suppose these are the two workpieces. When two workpiece joints, this is the electrode. Electrode is held by the electrode holder. In the flat position, the electrode is running this way. The angle of the electrode 60 to 70 degree we can fix, and the running is just like this direction. And if it is vertical, we kept two workpieces just like this. The electrode running from downward to upward, upward to downward. This is the position. Then if it is horizontal, the workpiece kept just like this, the welding left to right, right to left. And if it is overhead position, then towards the structure, the position just like this, and the electrode is running this way. These are the different positions which is necessary according to the time of joint designs.
So students, have you got this first video? Anything not understood or not clear? You can ask me. Everything is clear in the first video?
Yes.
Okay. So now I am going to play the second one. So this video is about your gas welding procedure.
Manifold system of the gas welding process. This means for the oxygen. This means for the CO2. This means for the argon. And this means for the
No sound echo हो रहा है sir.
acetylene. Yes, yes. Suppose we study about the acetylene manifold systems. This is the acetylene cylinder. How you can identify the cylinder? Color is maroon, short in height, big dia. Then this is the cylinder valve. We open the cylinder valve by the cylinder key. Then the gases pass through the stainless steel hoses. And this is the non-returning valve. And all, suppose here we are using at a time 4 cylinders. Series of the cylinders attached with the manifold systems. Then the gases pass through towards the station. This is the station. The station attached with the T-tapping point and then the ball point tapping points. And this is the regulator, the function of regulator to minimize the pressure, to control the pressure. These are the 2 flow meters indicate how much pressure inside the cylinder. Another is how much pressure going towards the work. The working pressure indicated here as well as there. There are the flow meters. Whether it is the flow meters indicate as well as cell and the working pressure. This is the transfer arresters. And these are the different fittings are attached. Then the gas flows to the pipelines towards the booth. After that, which you have already discussed at the time of gas welding or the preheating, brazing, cutting, these are different parameters and different flow of the gas will adjust there. This is the main for the purpose of oxygen manifold system. We can identify the cylinder. The color is black. Blue, it is indicated that black, long in height, small dia hemispherical shape. Then we open the cylinder valve by the cylinder key. Then the gas passes to the stainless steel hoses and non-returning valves also attached with here. Here also we are using 5 cylinders at a time. Then just like the oxygen acetylene manifold system, here we are using one another is flashback arrestor. No need of flashback arrestor. Before that, only flashback arrestor before the 1 point tapping points we have used here. Then these are the 2 valves. After that, it comes towards the regulator. The function of regulator that is minimize the pressure to control the pressures. Then the right side we can it indicate right side it is increase, left side is decrease. Then it indicate left side whether what is the temperature inside the gas, how much flow. In the right side, according to that flow meter, both are this and the pipeline, both are indicate same. After that, we can here open the T tapping points, then the ball point tapping points, then both gases, that acetylene and oxygen flow in the pipelines towards the booths. The purpose of gas welding in the manual process for the first year students. And these both two are the CO2 and the argons for the purpose of MIG welding and the purpose of TIG welding we study later.
So students, on this gas welding, do you have any query?
सर कौन सा गैस यूज हो रहा है वो बता दीजिएगा ना
Babuli sir, are you there?
Again the question.
So which gas was being used in that video?
In that gas we are using argon and CO2.
Carbon and CO2. Okay, sir.
Okay, when we are using in the MIG welding, we are basically use CO2. If you are using the argon gas, we can say that it's metal active gas welding process. Clear? Is it clear to you?
Yes, sir. Yes, sir.
Okay. Anybody have any doubt? Apart from that question? Okay. So proceed, sir.
So now we are going to discuss about the welding machine, the arc welding machine in the coming video.
First booth, second booth, first booth already we have discussed, that is the master booth, booth number 2, booth number 3, booth number 4, booth number 5. Or are the purpose for they may be used for the manual metal arc welding process or cylinder metal arc welding process, as well as tungsten inert gas welding process or gas tungsten arc welding process. And booth number 6 is for only the purpose of metal inert gas welding or gas metal arc welding process. And here we are using the different types of machines that we have already studied about, the step down transformer, and another machine we have, that is the inverter type welding machine. In the inverter type welding machine, that is produce the output voltage is low voltage and different parameters. Here it is arc force, then current, how much current indicates. These are different parameters. It is amperes, that is the voltage, the local modes and the remote modes, over current, over temperature, undefined mode. Current, minimum, maximum, increase or decrease, then arc force, whether it is that is a decrease, increase 0% to 100%, and it indicates here how much current we can adjust.
Okay, students, any query on this?
सर एक बार वापस समझा सकते हैं
Louder, I didn't get it.
प्ले कर सकते हैं समझ में नहीं आया मुझे
Once more.
यस सर
Okay.
First booth already we have discussed at the master booth, booth number 2, booth number 3, booth number 4, booth number 5. Or are the purpose for the may be for the metal arc welding process or metal arc welding process, as well as tungsten gas welding process or gas tungsten arc welding process. And booth number 6
Sir, can you please mute yourself?
Metal inert gas welding or gas metal arc welding process. And here we are using the different types of machines that we have already studied about that step down transformer, and another machine we have, that is the inverter type welding machine. In the inverter type welding machine, that is produce the output voltage is low voltage and different parameters. Here it is arc force, then current, how much current indicates. These are the different parameters. It is amperes, that is the voltage there. The local modes are the remote modes, over current, over temperature, undefined mode. Current, minimum, maximum, increase or decrease. Then arc force, whether it is that is a decrease, increase 0% to 100%, and it indicates here how much current we can adjust.
So have you understood it?
So आर्क वेल्डिंग हुआ कैसे वो समझ में नहीं आया अभी भी मतलब
Hello, कौन सा क्वेश्चन कौन?
So how arc welding is working? Like, I was not able to understand how arc welding was working.
How arc welding is used?
Yeah, how arc welding is used to join two metals.
Arc welding is a fusion welding process which is used to join metal to metals. An electric arc from an AC or DC power supply creates an intense heat of around 6500 degree Fahrenheit, which melts the metal at the joint between two workpieces. Clear?
Yes, sir.
And the source is the electric current, whereas we are using a machine, whether that is AC, whether that is produce DC, whether that convert AC to DC, means the transformer or generator or rectifier or inverter. Clear?
Yes, sir.
Arc is stuck between the tip of the electrode and the workpiece. When we contact to the two terminals, cathode and anode, we get spark for a very short time. Whereas the arc is the continuously flow of that current, and then the pillar metal melts and deposited between together. It fuse together, and that complete unit we can say that weldment. Is it clear to you?
Yes, sir.
Okay.
Sir, in arc welding, that rays are harmful for our eyes, sir.
So that we are using a hand screen
Okay, sir.
to protect your eye, face, neck from sputter, heat, fume, and the ultraviolet rays.
Yes, sir.
So that we are using a hand screen or a head screen. That depend upon the position, which position we have used, and that depend upon the structure and the joint designs. Clear? Is it clear to you?
Yes, sir.
Okay. Then, sir, proceed to next video.
So in the coming video, we are going to learn about various tools and equipments used in the welding procedure.
Welding system to prepare a lab joint in IC flat system by Arc Weld. For that, we cut the raw material, two pieces of IC flat having dimension 80 is the length 40 is the breadth, 6 is the thickness. 80, 40, 6 thickness. 2 pieces.
Sir, please mute yourself.
Equipments required. We have already discussed about that step-down transformer. Another machine we have also the inverter type of welding machines. Number 2, electrode holder. We have already seen arc welding cable, cable connector, earth clamp, hand screen, hand gloves, chipping hammer, wire brush, tongue, the common tools which we have used, base vise, hacksaw, flat file, then the measuring instrument, steel rule and tray scale. And just discuss about that different tools which are essential during the time of welding. Then here we have studied about the bench vise. This is the bench vise. The bench vise is the common tools which is used as well as in the fitting section. The purpose of a bench vise is holding the device. A holding device, it is a holding device which is hold that job at the time of cutting, filing, chipping. The workpiece is fixed in the bench vise by moving that handle clockwise and anti-clockwise. These are the two jaws, fixed jaw, movable jaw, fixed jaw, movable jaw, jaw plate. Then the body, then the handle. Okay, these are the different parts. Hacksaw, handle, frame, wing nut, returning pin, eye hole, blade. When you fix the blade, the teeth are forward direction towards cutting. Towards cutting. When you cut that material, just I'll show you the workpiece is fixed here. We cut just like this process. Just like this process, forward and backward, and your position just like this. Your eye should be concerned there. And just one step before, when you cut that material, the blade continuously, just like this, from cutting to end. Okay. Then this is the flat file. In the fitting session, you have already studied about that, the file, the specification of file, the classification of file. According to what is the specification? The specification depends upon the shape, size, grade, cut. Among that, from that shape, we have studied about the flat files. The purpose of filing, use the file is filing. What is filing? Remove the unwanted material for signing and right angle. Different parts, handle, farewell, tank, shoulder, face, tip, edge. These are the different parts of the file made out from high carbon steel. When you file just like that, the process, the position is just like that, forward and backward. You see here, after filing, the metal reduced and it is purpose for signing a right angle. You see here, after filing it is shown you signing. After filing, suppose when you are using, whether it is signing, whether it is for getting the accuracy, we have to check by the tri-square. This is the tri-square. Beam and blade, there are two parts of the tri-square. It is used for checking whether the workpiece is the right angle or not. Just like this. If between the blade and the workpiece after sliding, the light can pass, we can check whether that is perpendicular or not. Then we can identify the workpiece whether it is right angle or not. And we can getting the accuracy after that. Chipping hammer, the function of chipping hammer, chip the spatter and slag. Due to the long arc length, when we can weld that materials, the metal itself not deposited properly. At the time we can get the spatter, one type of welding defects occurs during that time. By the chipping hammer, we chip the spatter and slag. The flux after burning that electrode is cover the bead that is known as slag. That slag and that spatter removed by the chipping hammer. After remove the spatter and slag, from the workpiece. Then through the wire brush, we clean the surface. Steel wire with fiber handles. Tong is the welding device. Different types of tong we have studied about in the different sections. The welding, we have used the two types of tongs we are using, the flat tongue and the apron tongs are here. The purpose is for the welding the workpiece after weld. After weld, the condition of job is hot condition. That's why you use the tongue for your safety purpose. Hand gloves, it protects your hand palm finger from spatter and heat for your personal safety. This is a hand screen. Two types of screen we are using in the welding section, hand screen and head screen. Head screen looks like helmet. In the overhead and vertical position we are using the head screens. In the horizontal and the flat position we are using the hand screen. The body as well as the handle made out of fiber. Three glasses used here, two white glass and one black glass. You see, there are the three glasses, two white glass and one black glass. The black glass is the magnifying glass where you see the visible lights and the space during the time of welding. It protects your eye from the UV rays, and it protects also the heat and the spatter to your face. This is made out from stainless steel. It is a measuring tool, measurement of length and breadth. Accuracy is 0.5 millimeters.
Sir,
Yes, any query you can ask.
Any doubt?
no sir.
Hello?
Okay, then moving to the next video. Now I am going to show you the welding procedure. So in the coming video we are going to see the welding procedure. Okay.
Then we discuss about the procedure of the welding. Before that, this is the diagram. Single side joints. One is overlap each other in the middle. First of all, we have taken a mild steel flat size, the size of mild steel flat, dimension 160, because we have taken two pieces 80 and 80, already discussed. So one piece we have taken 160. By the marking tool scribble, we have to mark it by measuring steel rule. After marking, it is held by the bench vise, cut it into hacksaw, divided to equal 80 and 80. During the time of cutting, some materials also reduced. cutting, both surface, all sides should be filed by flat file for removing the unwanted material, for signing a right angle. After that, we have to check whether that is perpendicular or not by the price and measure for the accuracy by the steel rule. After cutting and filing, the metal reduced 79 from 80, 39 from 40, 5 millimeter from 6 millimeter. Because we have taken the raw material required size 80, 40, 6 millimeter. After filing and cutting, reduced 39, 6, and the length is 79. Then set up on the surface of the arc welding booth. Supply the current, got the machine ready. Adjustment the current, whatever may be the electrode diameter we have taken, into 40 plus or minus 20. And we have performed in the flat position so that we can set the electrode 60 degree to 70 degree angles. And before that, start the welding, you have to practice 1-2 electrodes on that surface of the table for your better confidence. And during the time of welding, for your safety purpose, you must have to use apron and gloves, full shoe, and hand screens. Then start the weld. During the time of welding, you run that electrode slowly. It will take some time for deposition and for good penetration. After welding, it holds by the tongue on the surface of the anvil. We start the chipping and cleaning through the chipping hammer and wire brush. After chipping and cleaning, then it will take 10 to 15 minutes approximately for cooling. When it's cold condition, after that, then write your roll number, section, branch, and then submit it to the concerned teacher for marking.
Yes, query student. Any query?
No, sir.
No, sir.
Okay. Now we'll see the cutting and filing procedure done in the welding experiment. In the coming video, we are going to see that the various filing and cutting procedures.
This is the hacksaw. You can fit the blade in forward direction. This is the pin, and this is the hole. Two side holes in the blade to hold the blade in forward direction in the hacksaw. And this is the wing nut, adjustable, and tight this the wing nut in hacksaw blade. And adjustable, cut the material direction forward. After cutting the material, one part and this part length is 80, width is 40, thickness is 6. After filing, length is 79 mm, width is 39 mm, thickness is 5.5 mm. Then to hold the material in this vice, first tight this handle in the holding instrument vice. This is the flat file. To file the surface and side to perpendicular, the purpose of arc welding process. File should be. This is the filing process. Complete this side, then other side will be filed and hold the material in this jaw at position. And this side will be filing. Complete this side, then surface filing. This position we position keep the material by using flat file. Then filing surface. Because carbon percentage more. Complete this side. Other side will be filing. Same process. Same process.
So this part is understood? Students?
Yes, sir.
Yes, sir.
Okay. So going to play the next video. Yes, Ashish, do you have any query? Ashish Patnaik.
The services was outside and the camera turned on.
Okay. So next video is about your welding technique that we are going to see, welding operation. Okay. So here in this video, the actual welding procedure we are going to visualize. And if you are offline, then definitely you could have handled the welding machines and done this operation by your own. And the feeling of the work with the sparklings, that you must have enjoyed. Anyway, now let us see what is there in this welding procedure.
This is the piece of material handling. This is the welding booth. This is the master booth. Other side, student booth. Manual metal arc welding process using welding arc welding section. First, you know what is lap. Lap is over the material on the surface of the material. This is called lap. And to keep this material in this table in flat position over the material. This position should be used in welding booth. Then this is the holder. Already completed this process. You know welding process. To hold the material in this holder, this is the teeth. Teeth should be flat, horizontal, vertical, overhead. To hold the flat position in 60 to 70 degree angle. Then this is the welding screen. Welding is ultraviolet ray to protect eyes. This is the welding screen. First you strike the material in the booth. First check the material will be spark. First spark. After practice, then strike the material. So, this is the weld material. Side. This is the tacking purpose of a welding. First tack. Two side tack. After complete this side, then back side will be welding. Long arc length. Then welding. You should check the welding outside of the job. Welding. After welding, to hold the material, it is hotted 3600 degrees Celsius. This is long tongue used in welding.
Okay, students, obviously if you have gone to the BMS lab physically, definitely this process of welding you must have done by your own hand. So this part is over. Have you gone through this part? Any query you want to ask about this?
No, sir.
Okay. So after welding, the final step is your chipping. So in that process, basically we try to remove the burnt slag, which came out of your flux material. So that we are going to see in the last part of the video. Okay, so I am no question. If no question, I am stopping this and playing the next one. Okay, now the last video of this welding experiment. This is about your cleaning the work material after welding.
Then chip the material. Cleaning and chipping use starter and material. Then use wire brush, clean the surface. This is the way. Then you complete the chipping and cleaning the material. After this is the sandbox, airbag. You put the material in this bucket because cooling the material.
Okay, so done. Any query on this? So since nobody is asking any query on this, so may I ask a question to all of you? Can anybody tell me after the welding why this chipping and cleaning is necessary?
Sir, because sear parts came out, sir. Like extra some parts due to the flux leakage, it came out. So we have to clean it. So the chipping and cooling process are needed.
I am just asking about the chipping procedure. For cooling procedure, you have seen the sand cooling is being used. You have dipped the workpiece material, the hot workpiece material into the sand bucket, isn't it? Why you have used the sand bucket? That will be the another question. Nobody is getting any query like this? Why you are using sand bucket to cool the workpiece material? Can anybody answer this?
So can you repeat the question?
Why sand bucket process is being used for cooling the workpiece material after welding. What is the purpose of sand cooling? We can directly dip into cool water, which is plentifully available, I think. In general, we can avail the water. So after welding, just put it in the water.
सर वाटर से वो मेटल जो है उसका स्ट्रक्चर खराब हो जाता है जहाँ तक हम
स्ट्रक्चर कैसे खराब होगा? Where you have
डक्टिलिटी वो हो जाता वीक है सर.
सर मेटल को एकदम झटके से नहीं किया जाता है जहाँ जहाँ तक हम जान रहे हैं. हाँ वो सैंड ठंडा करता है थोड़ा तो ज्यादा.
Then why sand cooling? Put it in the air, it will cool.
एयर से छत से
बहुत ज्यादा जल्दी.
So approximately you all have some kind of knowledge about it, but lot of theories are in behind of these concepts. So you must read and you can gain more of the knowledge about it. So for the time, I'm not going to discuss those theories over here. Most of the qualitative points you already have told over here. So that is the point, that is the thing we must know. Okay. So this is all about the video presentation of the welding lab experimental work. Okay, all of you are gone thoroughly through this, isn't it? Yes or no?
Yes sir.
Okay, so any overall questions, the concluding questions, if you have any, the final doubts, you can ask. Otherwise, we'll move on or proceed to conduct the quiz test for welding procedure.
Quiz sir, we are going to have quiz sir on welding.
Yes.
Okay sir.
हाँ.
सर अभी होगा.
Because we don't have further classes to conduct the quiz.
Okay sir.
So now it's the time. And final concluding queries, if you have to make about welding procedure, welding technique or welding section, do it now. And I think at exactly 1 p.m. we can start our quiz test.
From 1.
From 1?
Yes.
From 1 p.m. we'll start the quiz?
Yes, yes.
Okay sir.
Bhavli sir, are you there? Bhavli sir?
Sam.
ପିଲାଙ୍କର କ'ଣ ଫାଇନାଲ କ୍ୱେରି ଅଛି ଯଦି ପଚାରିବେ ଠିକ ଅଛି ନହେଲେ ଆପଣ ଲିଭ୍ କରିପାରିବେ ମିଟିଂ ଆଉ ଫାଇନାଲ ମୁଁ quiz କରିବି
ମୁଁ ଲିଭ୍ କରି ଯାଉଛି
ପଚାରି ଦିଅନ୍ତୁ ଫାଇନାଲି ଖାଲି So students, I am giving you 10 minutes more time and we'll exactly at 1:05 p.m. 1:05 p.m. we'll start the quiz. Okay.
Okay sir.